Hi everyone, welcome to my channel. Welcome to Daily Code Challenge. It's another beautiful day today, and we have another interesting challenge to solve today. All right, so a quick recap on what we did yesterday. Yesterday, we solved a function that accepts some arguments, and what the function does basically is it returns an array containing positive numbers less than the maximum numbers. But these numbers are expected to be divisible by either of the two of the three parameters. That's num1 or num2, but not both of them, right? That was what we did yesterday. The function name is called dynamic fixbus. So the challenge is actually called dynamic fixbus, right? Today we have something different. All right. Today is day 16, right? Let me close day 15. Here is day 16's challenge. So it's called least common multiple, also called LCM. Most of us know it as LCM. It says write a function least common multiple that accepts two parameters, num1 and num2, as arguments. The function should return the smallest number that is divisible by both num1 and num2. All right, so when it comes to least common multiple, it actually gives us the lowest common multiple of a series of numbers. So what that means is if we want to find the least common multiple, also referred to as LCM, which I'll be using from now on, if we want to find the LCM of 4 and 6, how do we get that? What we do is we need to find the multiples of each of the numbers, because LCM is least common multiple. So multiple, then we have the common multiple, then we have the least common multiple. All right, so let's find the LCM of 4 and 6. Here we are not writing codes yet, right? So I'll just say 4 is equal to, the first thing we want to do is we want to write some multiples of 4. Now what is a multiple of a number? A multiple of a number is simply the result we get multiplying that number by another, right? So for instance now, 4 is a multiple of 4 because 4 times 1 is 4. 8 is a multiple of 4 because 4 times 2 is 8. 12 is a multiple of 4. 16 is a multiple of 4. 24. What else do we have? 28. We have 32. Okay, let's stop here. Then let's also find multiples of 6. Multiples of 6, we have 6, we have 12, we have 18, we have 24, we have 30, we have 36, we have 48, we have 48, no, not 48 yet. Before 48, we have 42. All right, so these are not all the multiples of 4 and 6, right? But we want to stop here because we can actually go as far as going to infinite numbers. So what do we do? Having gotten the multiples of some multiples of 4 and some multiples of 6, now we want to find the common multiples. What does that mean? There are some numbers that can be found here and also found here. Let's check. We have 4 here, we don't have 4 here. We have 6 here, we don't have 6 here. We have 8 here, we don't have 8 here. We have 12 here, we don't. Okay, yes, we have 12 here. Also, we have 12 here. So one of the multiples One of the common multiples of 4 and 6 is 12. Let's check if we still have more. We have 16 here, we don't have 16 here. But we have 18 here, we also don't have 18 here. We have 24 here, we also have 24 here, right? So let's put 24. So going further, if we were to extend the series of our multiple of each of the numbers, we could get numbers which are also common, right, between both numbers. But let's stop at 12 and 24. Now we've been able to get two common multiples of 4 and 6. Thus we have 12, we also have 24. Then where does least common multiple come into play? Least simply means we want to find the lowest common multiple, the lowest of these two numbers. Here we know the lowest of these two numbers are 12. Therefore, 12 simply is the LCM of 4 and 6. All right. Similarly, let's try for 3 and 5. 3. Let's see some of the multiples of 3. We have 3, we have 6, we have 9, we have 12, we have 15, we have 18, we have 21. Let's stop here. Then let's look for the multiples of 5 as well. We have 5, 10, 15, 20, 30, oh sorry, 25, 30. Let's stop here also. All right. Now let's look for multiples of, okay, let's extend this 3. We have 21, we have 24, we have 27, we have 30. All right. So here we can see that we have 3 here, we don't have 3 here. These are not common. These are not common. This also 9 is found here, 9 is not found here, 12 is found here, 12 cannot be found here. We have 15 here, we have 15 here. So one of the common multiples of 3 and 5 is 15. Let's check if we still have others. We have 18 here, no 18, 20 here, no 20 here, 21, no 21 here, 24, no 24 here, 27, 27 here. Same to this, 20 and 25 cannot be found as multiples of 3 also. But here we have 30. 30 is a multiple of 3. 30 also is a multiple of 5. So another common multiple we have between 3 and 5 is 30. Then what then is the least common multiple? Least common multiple is the lowest among these common multiples, which we can see here as 15. So we understand that the least common multiple or the LCM between 3 and 5 is simply 15. All right. Having established that, how do we now write that in code, right? To put this into code, to implement it into code, we need to look through 1 from 1 down to the product of num1 and num2. Excuse me. Num1 and num2. So reason being, so the reason why I want to look between the product of num1 and num2 is because we actually want to iterate through all the possible values and multiples of both numbers, and we can only get them using the product, right? So for instance now, we loop from 1, 2, 3, 4, 5 down to the product of 6 and 4 is 24, right? So having done that, then we look for the number among this series that is divisible by 4 and also divisible by 6. That number simply gives us the LCM. That number simply gives us the LCM. For instance, let's write all the multiples here. Sorry, let's write all the iterated values. Excuse me. So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Then we have 24. Looking at this series here, let's look for the numbers that are divisible by both 4 and 6 without giving us a remainder. What are the numbers? Okay, so 1, yes, 1 is already established, so we are not going to use 1. When we say 1 modulus 6, it gives us 1. That means there's a remainder. When we do 1 modulus 4, it gives us 1 as well. Let's try this and see. Let's try this using the code. Let's just do a console log. Console log 1 modulus 4. Then we save this and we run this. We get 1 as our answer, right? That means 1 is not part of it. Let's also try 1 modulus 6 because here we are dealing with 4 and 6. I save this and when I run this, we get 1. Similarly, when we look through 1, 2, 3, 4, and 5, we are going to be getting remainders. But here you will notice that when we use 6, 6 modulus 6 gives us 0. That means we have a number that is divisible by 6 without any remainder. But 6 does not work for 4. Let's do 6 modulus 4. This will give us 0. This gave us 2. That means 6 is not the LCM. Eventually, we will get to the point where we have 12. And then here, when we do 12 modulus 4, we get 0. Also, when we do 12 modulus 6, we get 0. That means that 12 is the LCM. Although 12 is not the only number in this series that is divisible by 6 without any remainder. We have 24 as well. But the lowest between 24 and 12 is 12. That makes 12 the LCM. Similarly, that goes for 3 and 5. You can try that out. Also, if you try for 2 and 10, using this pattern, you are going to get 10 as your LCM. Okay, so having done this theoretical aspect of it, so I want to believe that we understand the theory behind this. Let's move straight to the code implementation. Okay, so I'm simply going to zoom this in and then do this. All right. All right, so let's read the instruction again. It says, write a function least common multiple having two parameters, num1 and num2. The function should return the smallest number that is divisible by both num1 and num2. So what that means is that we should find the LCM between these two numbers. I am going to write the function here. All right, so I say function then I remove that name and I change it to least common multiple. Also, I am going to move these params and then replace it with num1 and num2. Excuse me, num1 and num2. All right. Then we want to create a for loop that is going to loop through from 1 to the product of these two numbers. That is something we established here already, right? We did 6 times 4, 24. That's why we iterated between from 1 down to 24. So that we can actually get all possible multiples of both numbers. That's just the logic behind multiplying 4 and 6 or multiplying 3 and 5 as the case may be. All right, so that's what we are going to do here. We are going to simply say for. Here we replace index with I, one of the common things I do most times. Then I remove array.length because we are not working with array yet. And also I remove this line of code. Okay, so we here we are not going to start our counting from 0. Let's start from 1. So we don't have issues with our code since we are dealing with multiples, because we understand that 0 multiply anything gives us 0. So let's be careful of how we use 0 when it comes to things that deal with multiples. Okay, so here now we are simply going to say num1 multiplied by num2. Now, do we need the last number to be inclusive? Yes, because the LCM could actually be the last number, right? We don't know that for a fact anyway, but to be on the safer side, we include the maximum number. The next thing you want to do is let's console log I and see what we have first. So that means that we want to loop through from 1 to whatever is we want to look from 1 to whatever is going to be the argument, the product of the argument to be given to our function. Then I put I here and I save. Okay, so let's call the function and then place in some arguments. We say list common multiple. Let's use 4 and 6. 4 comma 6. Here we need to console log what we have. Console log this. All right, let me save this and then run. Okay, so we can see that here we have the iterated values running through from 1 down to 24. All right, so that's established now. Among those numbers that just got returned, like I said here, we have we have the least common multiple from among them. And how did we get that here? We iterated and then we look for the number that is divisible by both num1 and num2 without any remainder. So we are simply going to comment this log parts and then write a conditional statement. We say if I, which is the iterated values, each of the iterated values here represents I. If I modulus num1 equal to 0 and I modulus num2 is equal to 0, console log I. Let's console this. Let's remove this from here and then place it here. And then let's remove the comments. So what this basically means is we want to look for that single number that is divisible by num1. In our own case, num1 here has an argument of 4. So this number is divisible by 4 without any remainder, and this same number is divisible by 6 without any remainder, looping through from 1 down to the product of those two arguments, which is in this example 24. All right, so I save this. Here I don't need the console log anymore because we have console log in the function already. Then I'll remove this last bracket here. I save again. Let's run this code and see. All right, here we can see we have 12. We also have 24, but we are expected to just get one value. What possibly could be the issue? What possibly could be the issue? All right. So in this case now, we said console.log. What happens here is that it's going to log out every values of I in the series that satisfies this condition. 12 satisfies this condition. 24 also satisfies this condition. So what we are going to do simply is instead of using console.log, we simply use the return statement, because what's part of what the return statement does is, after having the first encounter that validates the conditional statement, the loop stops, the iteration ends. So once it gets 12, which is the first value, it breaks out of the function because the loop ends. Then we are simply just going to return I. We return I here, and then we come here, do console.log, because we no longer have console log in our function. Therefore, we have to place it in here. Let's save this. Let's clear this console, and then let's run this code again. All right, so now we have 12 as our answer, which is the expected value, right? All right, let's also try some other numbers. Let's try 3 and 5. 3 and 5. Let's comment this first one. So I save this and I run this code. We get 15, which is correct, because here it says least common multiple LCM of 3 and 15 is 5, is 15 rather. Okay, let's try another one. Let's try 2 and 10. So we are expected to get 10 as our answer. 2, 10. Let's comment this second example. I save this and then I run this code. All right, so we have 10 as our answer, right? Wow. We've been able to achieve the correct implementation of what the coding challenge is all about. We've been able to successfully write a function that returns the LCM between two numbers, right? So I believe this was fun, though it's quite a challenging one, but I believe we learned one or two things from it. Also, we can also choose to extend this by improving on our function to be able to get the LCM between more than two numbers. So I think I'll just leave that to whosoever that is interested. But for this function, this challenge, we've been able to implement the correct solution to this challenge. All right, so with that, I say thanks for joining on this call. I'm so excited to have made this possible and also having you around, and I also am excited to be here as well. So I'll simply just say thanks once again for joining in on this call, and see you tomorrow. Hope to see you tomorrow, and stay blessed. Bye.